So what we got going on, we got to bore this out. We have to take a total of 4/1000ths out of the bore. It has a very nice, pretty bore. That is 2/1000ths per side. We don't have a lot to make mistakes on, and they want it really, really accurate. They didn't say plus or minus nothing, but pretty much that's really what they would like to have, which is impossible, of course. But we need to definitely be within 0.5 and preferably within 1 or 2 10,000ths of an inch. So pretty close they want it. So to start with, first off, Austin started putting it in, but we need a little bit of clearance here. We need to have 1/2 inch at the back here. Give us a good half to 5/8 at the back here. So we got some clearance from the chuck.
Okay.
And that we don't need quite that much if we get by with boring this, but we're going to try some boring cuts. We're going to try a boring cut at least at first. And I will actually do the cutting.
Oh, thank God.
Yeah, I just thought I'd let you get it set up and mention a few things about what we're doing. But
Yeah.
I'll do the actual cutting, and if it happens that the cutting works out, okay, great. We'll call that good, and it will be a win for us. But we bid enough on it so we can set up the tool post grinder and grind this into size if we need to.
Okay.
The original finish is not a ground finish, but it also is 4/1000ths off of the specification for the part. I think the reason for that is that the specification for the part is copied over through time from notes and in 1946 when they originally made this machine. But when you have a multi-million-dollar machine in 1946, they get rebuilt and reused.
Yeah.
They don't upgrade them. They upgrade the electronics, motor controls, things, but the basic machines on some of the really big equipment, it goes from a mine, gets torn down, goes to a storage facility. There's guys that's their whole business is storing this stuff. Because when a mine is done, one of these big hard rock mines, when it's done, they either sell the stuff for near nothing or they literally give it away for somebody to take it. So it cost them millions when they bought it. And that machine right now is probably worth $50 million for a general used one.
Wow.
But when it's done, the shipping on it is going to cost you $10 million.
Right.
By the time to take it apart and ship it. So how much is somebody going to pay for it? A lot of people, they pay zero. And then they pick it up, they move it in pieces, take it to a central storage location, wait till somebody else needs it. Normally don't sell it used. What they'll normally do is sell it refurbished. So by the time it's a refurbished, then they've got extra they spend on top of their cost of moving it, which would probably be less than $5 million because they're going to do it with their own equipment. They set on that for 5, 10 years. Then they spend another $10 million into it to refurbish it and sell it for $100 million. So that they make profit.
Yeah.
And good for them. Anyway, a lot of this stuff gets recycled, but
What?
some of the information, this is on a big gyro cone crusher.
Oh, okay.
Yeah. So big one.
Explains the shaft.
Yeah. This is for the main motor drive. Anyway, so the information a lot of times though is something that was written way back when, and it isn't always updated. Today, if somebody was writing it would say it's supposed to be this size, plus or minus 2/1000ths, or plus or minus 1 or 1/2, or some kind of a number. All they have is the number it's supposed to be. This doesn't match the number it's supposed to be. This size might work. They even acknowledge that, but they don't want to risk the damage if this is wrong. Because it will do damage if it's enough off to be a problem. So they just want to stay with the number that they have, and I understand that. The thing that can damage on this, what will happen, this is shrunk on. You have shaft, solid, nominally cold, and you heat this up and you slide it on. Don't go sideways at all on the key or it really sucks because now it's stuck before where it goes, plus the key is stuck. That can be a problem.
Yeah.
Make sure when you're doing one of those, test the key in both pieces first, check it, make sure. Anyway, it's pretty interesting, cool, it's fun. I like doing them. First one I ever did just scared me to death. But once you get into these, it's like, because very few people do it, and the ones that do it, you get it right, it's perfect. You get it wrong, it's stuck and you have a problem. The worst one, a friend of mine, he was working on one. They'd heated this thing up for, I forget what he said, 3 days or a week or whatever, but it was literally a 20-foot diameter pulley that they were putting on.
Wow.
And they got it on about 1 foot out of the 3 foot it was supposed to slide on.
Oh, no.
And it was a one-time install because it was supposed to be so tight. And the only thing they could do was, I forget what he said the pulley cost, but it was cut the pulley off and go get a new one.
Oh.
That's the other side of, and that's why they want this right.
Okay.
Because if this is too tight, what can do? Now, if we know in advance that it's too tight, we're never going to take it off, we pre-freeze the shaft with liquid nitrogen to help us more.
Okay.
Okay? We pre-freeze the shaft with liquid nitrogen. We heat this up to the maximum we can without getting in trouble, which is probably about 400 degrees. And we slide it on. We go, hey, we're cool. But here is where the real problem comes in. They wear these out once in a while. These outer, there's a movement here as this coupling takes up for misalignment. They've got grease in here, little pieces that go in between them. But it wears out. So when this wears out, you want to replace it.
Yeah.
Here is the problem. You take torches and heat up the outside of this to expand it enough to pull it off the shaft. If you can't get this hot enough, quick enough, it starts heating the shaft.
Right.
Now it never comes away from the shaft. And if your fit is too tight, just like on that pulley I was talking about that my friend was working on a crew and it stuck, you don't get it back off.
Yeah.
It's a one time. There are certain bearings, certain things that are meant to be heat shrunk on one time, and it's a relationship of how tight and how much metal is here versus how much shaft metal. Now in this, you're looking at this, and this is not that much metal in relation to the shaft metal. I mean, you got a good chance getting this off. I don't see this as a real problem, but still, knowing that those things happen, you got a very expensive machine that costs, is probably making them somewhere between $50,000 and $250,000 an hour when it's down.
Ooh.
Yeah, that's besides what this thing costs, which I don't know. Anyway, bottom line is they really do want that magic number. So that's what we're going to do, is give them the magic number that's supposed to be right.
Okay.
So now, if we can, we will try high RPM. I've got a nice boring bar over here with that'll take CBN inserts, and we'll try that because that tends to cut a little bit better across intermittent surfaces. It doesn't always give a real good surface finish on soft material, and this is somewhat soft. So it's either going to start out and work or it's not. And if it doesn't, I'll go right away to a tool post grinder.
And we need clearance so that we don't hit the chuck.
We need clearance so we don't hit the chuck. We need clearance so we don't hit the chuck if we use the tool post grinder.
Right.
So this, if we look at the tool, the boring bar that I'm going to try at first, if you had a 1/16 of an inch, you could do it. I'd rather have an 1/8, but a 1/16. But the grinding wheel will be a 1/2 inch wide grinding wheel.
Okay.
So we need a little bit more clearance here in the event that we do go to grinding. And that was how I bid the job, was figuring we'd have to spend the time to grind it.
Okay.
Now, another thing happens here. Our ways on this could be tightened up a little bit, and we will. We're not going to bind them up to where it won't move, but we're going to bind them a whole lot tighter when we get down to the position close to diameter that we want to be. We're not going to make our movement with this, even though we have the nice readout. And look, it even reads in tenths. But when you read in the tenths, it actually, I think this one goes by, okay, this goes by 2/10, which the 2/10 is plus or minus 2/10 also. So it's better than one that doesn't go to a tenths position, but it really doesn't tell you where you're at. So we go to the old school trick for doing this, which the old school trick to doing this is we take our compound, and it's still loose from whatever we were doing last time, and we set it over here, and we dial in an angle on it so that in 1 inch we have 50 thousandths movement on our indicator,
Okay.
which is the same as 100 thousandths would equal 5, or 10 thousandths equals a half.
Yeah. Okay.
So now 10 thousandths on this dial, which is actual movement, We'll move this a half of a tenth, which means that, well, each move, excuse me, 10 thousandths would move this a half, yes. 10 thousandths there will move this a half, which is 1 thousandths. So 1 thousandth movement on the dial will move this a half of a tenth. And the half of a tenth will give us a 1/10 thousandths cut, which you don't normally have a way to dial in on a lathe, but by using your compound, it gives you a way to dial in that finer amount.
That's really clever.
Yeah, and it works, and it's an old school, one of those tricks,
Yeah.
part of one of those knowledge tricks, whatever. So we will set up for that, and what I'm going to have you do here, I'm going to walk away, do some other, in fact, I'm going to go put in our magic pin for Google World. It came in the mail.
That was fast.
Yeah, well, I thought a week and a half was, but they did say up to 6 weeks, I think, so it was faster than what they said, and it's here. It's a number. I'll see if they like me. Okay, so what we want to do, want to pull this out a little bit. We want to rubber hammer and put something across here just in case you goof up and this wants to fall.
Okay.
Piece of board across here is best. And try not to let it fall because it's kind of heavy and hurt your hands and stuff too. But basically you loosen 2 of them, bring it out, retighten it, and you'll be pretty close in there. Put an indicator on here as you first tighten it and get this just straight, okay? Then once you get that straight by tapping it, then dial it in back in here. Dial it in back here.
Oh.
Yeah, dial it in back here, and you have to go forward and backward so you're not running into the key.
Yeah.
And then, that was the other thing, I'll get to that in a second too. Then run out here to the end and do the same thing, but obviously we can't dial it in twice. So what this will do, while getting this true, got us started with where we think they made it, but that may not be where they made this bore. So when we dial it in here, in our jaw, that gets it true there.
Okay.
With the bore. Then out here, we still haven't super tightened it. You don't super tighten this till we've got everything where we think we want it, and then you start tightening it, just snuggish to start with so you can move it. So then we come out here, we put our indicator, and we find that it's off by whatever, 1,003, whatever to start with, and we tap it with our soft hammer so that we bring that into position and get this running true. Because we had it true here in the jaws, it's going to kind of stay there.
Yeah.
Now, the fact that we move this also moves it back here a little bit. So then you come back, dial this in again with the jaws, come out here and tap, and you go back and forth until it's true and true.
Okay.
And initially, like I say, you start here so that you have it where you're not fighting it as much on the bore. But once we go to doing off of the bore, you ignore this, because this may run out at the end of the day. They may not have made this exactly perpendicular to the bore.
Yeah.
And what we need is to match the bore, because we want to be cutting on the same bore that's there now.
Yeah.
So that and then the other thing I'm going to do, I'm going to start setting up a bore gauge, because the bore gauge, we looked at those real quick when we were looking at measuring tools, is a nicer way to measure this than other things. And since we have an agreed upon number that agrees on my mics to within a tenth, agrees with the customer's mic, we'll set our bore gauge to that number. And then when we're looking for the number we want, we know that all of our mics and everything will agree with that increase in size.
Okay.
So we're essentially using this as a setting gauge, because we all agree right now that this is, the last number is 2. I forget what the rest of it is. It's written down somewhere. And we're going from 2 thousandths to 6 thousandths on the bore size.
Okay.
So basically, we won't even worry on this since we're not doing a full we'll set the dial gauge in here. We'll set the dial on 2 thousandths, and we'll be looking for 6 as our answer. So that's how you get it fairly close. And we're off quarter, half a thousandths. It's close enough. Close. Are we on there? So we got the bore gauge set so that it reads 2 thousandths when it's in the hole, and it's pretty consistent. There's one place it's about a quarter over because there's a little bit of out around and maybe other places that I missed, but pretty much the size we've got. I was speaking yesterday about using CBN and seeing how that would work before we resort to using a grinder, and after thinking about it, that was just plain a silly idea because we really don't have enough to take off to get a good chip depth with CBN. So what I'm going to still try cutting at first, but I'm going to go back to plain old school. Just as I've told other people, high-speed steel. I was going to take a file and check this real quick, but I do believe that this is soft. Yeah, it's relatively soft, as most of these couplings are. I hadn't checked it before, so the high-speed steel will work. We just put a smooth coating of cutting oil on there when we go to it, and we'll still use our micro feed method here. So have we got an indicator with a travel indicator? I know Austin's still got all the others tied up.
Oh, I just put it away.
There's our 19, I think. Yep. People that were watching might have wondered why I was moving the carriage around over here, and that was because I could clamp on the part better to get my indicator mounted than on the bed for what I'm looking to do for measuring this. We don't need to have exactly our 50 thousandths per inch, but somewhere close is good. And tighten that up a little more there. So since we're at this holder's wonky. Some of these do that. They get to where you can't tighten them all the way. And what that is with these Noga holders is this little nut back here backs off. So you're going to back off the pressure, and then this one here is kind of loose. And you just reach in. There's probably a tool for it that I don't have. And you can tighten it up a little bit. And then when you tighten up your lock, it will become more rigid. It's kind of amazing that quarter of a turn made so much difference on it. Normally I've got to turn them a couple turns before they come somewhat tight. Okay, so same thing, back to 0. And what I'm looking at is off of, it's probably closer to center there. Looking off of center, and if I 0 out my readout there, if we come back this way by 2 inches, that was already 100. I guess that's actually going to be fairly close to what we were looking at, because for 2 inches we should be 100 thousandths. And starting at the center, that means we should be relatively close by doing that, which I don't know that I was exactly at the center, but if we go from 2 now back to 0, And I'm off by 1/1000. That ain't gonna make enough difference to matter. So today, I'm not gonna care. Some days we will, some days we won't. In this particular case, it doesn't matter. It's just a relative amount. We're trying to use the scale here so that our feed will be less so that each one of these 1/1000th movements on this will actually progress us. We are gonna have to do that again though, because I set this in the wrong direction. I mentioned to Bert about making sure you put that in the right direction, and then here I am on the video, not thinking about it, just trying to go forward and show how quick and efficient I am as the old guy that's done it a lot. So, yeah, okay, we will do this again, because it needs to go to the other side. It needs to be so that when we feed it in, it is going to bore out more. Didn't get those yet. Okay. So, about the middle of that again. Go to 0. There's our 100 again, except it's in the wrong direction. So now what we'll do is we'll come back to 0 and 100. And we will just barely snug a part. I'm at 0. I'm going to go ahead and do that again. And if I come back here to 100,000, I'm way off. So how far was I off? Let's go all the way to 2. Let's see what I got. So at 2, I am an extra 17 thousandths. So if I come out here, or pick a new, what looks closer to center again, go there. I come out about 2 inches. And I should be able to go back about 17, or actually to 0, the way it's lining up again. Now we'll go back over here, see if our numbers come close. Oh, which one's going to beat? Oh, I went too far. Again, off by 1/1000. Okay, I left it last time, I'll leave it this time too. If we were setting a taper that had to match with another taper, that would be a whole different thing. And we would go for the extra, making it accurate. But it really isn't going to matter in this place if we, out of a movement that we make, we're off by a micro inch, which is a millionth of an inch or a thousandth of an inch, and is just, it doesn't matter. It don't have to be that accurate. So back to our tool bits. Boring bar, I was looking yesterday, I saw that one there is big. Maybe it was in the drawer. Maybe I was just thinking because I saw the boring bar that was for the bigger lathe that won't fit on this one. So I think that was the bar I was thinking of. I was looking for one with a slot in it. That's way too big. That doesn't go here. This one could come out and get used and have a individual tool. Rather have a bigger tool, bigger bar, but that's good enough. So I think that was a 5/16. Corners a little bit first before you try putting it through, unless you're needing absolutely perfect corners somewhere. And then you take the broached hole and you take a file on the inside of it and make it larger, but that's a lot more work. I could wait and check later. Some of them they will go through without doing that, but I just thought I would do that to start with. It's just not wanting to go in. There it goes in, there it goes in. It's not going in right there for whatever reason. It's definitely off size. This is actually going to be the easiest. It'd be to just put it on our surface grinder. Let's flow around. Put it slightly sideways so that it catches some more lines of magnetism. If I put it in line, you see the pole spacing. It doesn't catch much magnetism if I put it straight in line, which straight in line means I have to do less to grind it, but it won't hold as well. If I put it totally crossways, it will really hold good, but then I'm going to be all day long cranking this in and out for, don't really need to. It's not that critical of a sizing. Totally not correct for precision grinding, but it will do what we need. How did I get that so accurately, so right? I don't know. Because I really wasn't measuring or even looking at the marks correctly. I was just grinding a little bit. You can also grind the top with the grinder. One of the ways that you're not supposed to do it that works pretty good is on the side of the wheels. That stays fairly flat. Sander doesn't work too bad. Yeah. The actual cutting edges that we're going to have here, which looking at the bar, the sizes that these are already, the angles looked pretty good. And we'll come over here, and I want to have a little bit of a radius, because we're going to do an old style finishing tool, which they normally made finishing tools in the old days that were right hand or left hand. And they really were not any different than the one that they called just a round nose tool. I think an awful lot of those tools, I think somebody came into the shop and drew them off of things that guys were using that were more free form and decided these were standard tools at that point. I want to have a little more positive of a rake at the start, so I'm going to come in here. Dress the top at an angle. And then we're going to come over here because we want a really nice finish on this, even though these are not normally what you use for grinding high-speed steel. These are normally for carbide. But it puts a really nice finish on the end. And if your boss doesn't catch you, you can see how much better the finish is on that part that's ground with the diamond. If your boss doesn't catch you, you can sharpen your pocket knives on those really good too. But if you do too much steel without using an abrasive cleaning stick on it, the steel will clog up in between the diamonds and they won't work well. That's why a lot of steel grinding on them is not that great. Just slightly higher. I decided to get fancy and measure it this time.
Nice.
A lot of shops will make little tools that come off the bedways or leveled tools and different things. And I used to get real excited about those kind of tools years ago, but most of the time eyeballing it just saves time. It works for most stuff. Now, on this one again, we're trying to be very precise. So if you're off center, your numbers don't come out as good.
Okay.
If you're on center, then you're at the diameter. If you're above or below center, you're at a point here when you come out of thousandths. Thousandths off of this is more at the diameter because you're coming at an angle. And 1/1000th movement in here will cut more.
Yeah.
So the closer you are to center, the more repeatably accurate you are again. Now, we need to do something else. I don't want all of this movement and slop around in the cross slide. If the cross slide is moving, and I don't remember whether this is a single screw or a double screw. There's a double, so it takes two screws to tighten the gib. Yep. The shorty is nice for the back.
Yeah. Unless you have really long arms. So do you have to tighten those the same amount?
Well, you loosen the back one,
Oh.
and then you run the front one where you want it, and then you tighten the back one again, so that it's holding both sides of the gib is what you're doing. You're pushing it from both sides. And part of this, we will revisit this, and we may not have the gibs as tight as what I'm going to make them now, but we will leave them tighter than they were. They were getting a little sloppy on this machine anyway.
But you don't want them that tight all the time?
Not as tight as I'm going to put them now. I'm going to put them a little too tight on the lengthways ones, where they're actually harder to move than you should, because I'm going to use the feed there, and I want these to almost be a lock.
Yeah.
I'm still going to use it as a major adjustment, but I want it to almost be a lock. Not quite, just. Just starting to get a little bit sticky right there, which is kind of what we want. I don't have to go far. I will do the initial picking up with this, and then it'll be just a matter of moving the other dial for our actual amount of cut. Start out with it at 0. This is kind of an interesting question here too, because the way this has been working, when we turn on, we do not want speed anywhere near 1600 or 800. We're going to, let's try 280. Done at slow feed. 5 was slower than 3, but 3 is kind of what I usually use on this one. And I will touch off before I put oil on it, and then we will put some cutting oil on there. I slowed it down a little more while you were gone.
I hear that.
Yep. Because where I was, in fact, before I even touch off, I'm going to do the paper thing. Because it was vibrating a little bit, had a little balance issue.
Because of the keyway?
Yeah, I hadn't really thought about what our weight was, but yeah, the keyway without a key in it. That is exactly what it was.
And you were hoping to run this at a little higher speed, right?
Not for this. When I was thinking CBN, I was hoping to go for a higher speed, which CBN was just a wrong idea. I do that sometimes. My better work comes after I've slept on it, thought about it, done some other things, ignored it, thought about it again.
That's pretty common.
Oh, I know what I was going to look at. I didn't there. Was in the past, every time you pull the clutch in, it was jerking, and it still did a little bit there too. I don't know if that's the scale. I'm going to shut that off. If it's the scale or, I mean, this is not moving now. Yeah, see that scale,
Yeah.
it's not 100% to be trusted. Okay, that pretty close. Yeah, we're gonna have to look at that scale. That is not a good situation. Okay, so I am touching. See my little touching mark?
Yeah.
Okay, so now we want our brush, the cutting oil. Because this is slow enough, low enough cut. I don't need to be trying to put cutting oil on here all the time. I just want to brush it on the whole surface. So it will bleed around and be okay pretty much.
I'm just waiting for it to settle down.
Yep. The hardest part about this right now is I want to make sure I don't touch my cutter at all.
Yeah.
My cutter, my tool, you know, any of the things that we just set, because we realistically could move it. And I don't want to. I just touched it there.